Hi everyone, Faisal. So as I was saying, I spent the last couple weeks or more just going through Fuchsia and trying to understand what it is and why should I care as a developer, or should I care even now, right? One of the things I like doing is trying to get in technology early and explore and see, is it the right time for me for my personal goals? And my personal goals as a developer is not building hardware, it's to build software, build mobile apps. So this entire talk is given through that lens. Is it ready for me? My background is in Android development, iOS development, Flutter development. I do a lot of Flutter right now. As well, I do a lot of systems design and cloud work. And so for me, it's not important if Fuchsia is ready to be running as an operating system. It's important, is Fuchsia ready for me as a developer of consumer apps or B2B apps, for example. So this is what this whole talk's about. I'm going to start sharing my screen here, and then we can go over it. If you guys are lucky, my emulator will work. On my other screen, I have the emulator booting up. If it works, great. If not, no problem. We're still going to see a lot of Fuchsia internals and understanding about what Fuchsia is all about. So if you see me looking at that screen right here, that's because I'm trying to see if my emulator is running. Cool, so this is a brief introduction. By no means this is a thorough deep dive of all the technology behind Fuchsia. I think that would be very hard to do. As well, I don't have the deep operating systems knowledge to even convey some of the cool design patterns or do justice to it. So I do recommend you guys, if you're interested in the operating system part of this, like the internals of it, then check out fuchsia.dev. This talk is inspired by two really good presentations that I've seen, as well as a bunch of reading I've done on all the fuchsia.dev website. There's a talk, not a talk, there's a presentation, a podcast actually, by Eric Seidel and Adam Barth, I think, on rubber duck engineering. And there's another one from last year. I don't have the name of it. It's a really intelligent French presenter that goes through the entire talk, and I was blown away by it. So I'll share links to that in the slides after. So let's get started. We're going to be talking about a couple things here. Number one, what is Fuchsia? Why Fuchsia? We're going to talk about the architecture. We're going to explore Fuchsia, either if the emulator works, or we're just going to go through the source code. I'm going to talk about how apps are built. You can visualize it anyways. We're going to be looking at Flutter in Fuchsia. And then next steps. How do you as a developer start getting your hands dirty in Fuchsia? So let's talk about why Fuchsia, right? Let's step back. What is an operating system anyways? You know, I think it's very clear to everyone what an operating system is. Mac, Windows, Linux, Raspberry Pi OS, whatever. Most of these operating systems are built on Linux. Then you have Mac and you have Windows, which are built on whatever internal stuff that they're doing, right? Unix for Mac, I guess. And then Windows has their own NT kernel. But let's take a look at it from a philosophical aspect. And really, this is where Fuchsia comes from. Philosophically, what is an operating system? They're a byproduct of their time. So if you go all the way back to probably before most of us were born, you had DOS. I guess Bill Gates or whoever these guys were came out with DOS and a bunch of these other operating systems for systems that were built for that time, and they predicted the future. And most people, no matter who you are, even if you're Bill Gates, you can't predict 20 years down the line. You're predicting based on market trends, and so you're like, you know what, DOS is a good operating system for the next 5 years, 10 years, based on how we're seeing the market grow, based on the innovative ideas that we have. And so the features that DOS has, the architecture that DOS has, is built around that thinking. And then you started seeing a trend of cheaper computers, monitors, mouse, and you started getting GUI on all these operating systems. And so when you start thinking about Windows 98 or 95 or even whatever was before it, I have no idea, then you have the first versions of Mac, very primitive designs in terms of their UI. But even if you look at their architecture, you have this like monolith kernel, or however NT is designed, and then you have one unified file system. You have applications that just run and can like talk to other applications very easily. There's not a lot of security involved. And as we started getting more and more mature, systems got more complicated, more people were doing more mission critical applications, using computers for that. Computers started getting security, right? I remember in Windows 98, there was a protocol where I could just send a message to any other computer in the world and it pops up right on the desktop. I don't know how many people remember that, but that's what it was. And so that's crazy to think now that from command line, you can run a command and send a message to any IP in the world. But that was the thinking back in the day, and that was because of the current times that people were living in. And so then you have this explosion of mobile. And when you think about really what started this explosion of mobile in a very consumer-friendly way, that's iOS. And iOS was designed a long time ago now. I was in high school, and then Android came out. And both of these mobile operating systems were designed, again, for the mobile phones at that time and predicting 5 years into the future. How touchscreens would look, how users are going to use these applications, right? If you think about iOS, it didn't even have an app store for the first version or two. This was never an idea that you could run and install apps on a phone. It was just intended to be a phone with some productivity features, with Safari and whatever, right? So the operating system itself wasn't designed with all these things in mind. And so now you look at 2015, 2016, and I won't mention who this was, but I remember talking to someone who had just started working on the Fuchsia team. And I asked this person, what is Fuchsia, right? This was like, you were just starting to hear inklings about it. There's a lot of misinformation that they're building an operating system based on Dart and Flutter, which it absolutely is not, and I'll talk about that in a bit. And this person told me, the thing that keeps, and this is more of like an analogy, I don't think this is an actual word for word, but he said to me, the thing that keeps Larry and Sergey up at night is there's probably someone out there building something so innovative that's going to shake the core of Google, right? And just like make them obsolete. And so Fuchsia really comes from this idea of, let's think about the future now based on what we see modern technology is. And by 2015, 2016, even now as Fuchsia is being developed, phones have become such an integral part of our life. The technology has become so important to us that we can't function without technology. Technology is as important to us as water is in most cases, right? You can't do anything without it. But back when operating systems, DOS was invented, that was not the case. And so that is why Fuchsia is being developed. It's to take advantage of the current landscape of technology, predict 5 years in the future, 10 years in the future, what technology is headed, where it's headed, the vast amount of devices we have, and the vast amount of surfaces that these devices need, right? You have your phone, you have your TV, you have your laptop, you have your refrigerator. All these things run operating systems. All these things need some sort of user input in many cases. And so that is why Fuchsia exists. So you might ask, well, why not just use Android, right? Google has a fantastic operating system already. Why aren't they just using Android? Why are they wasting time with Fuchsia? And to that, I would say, look, when Android was created, it was, again, a byproduct of its time. Android also has a lot of problems when it comes to like the kernel, security, all sorts of things. So this is a fresh start altogether. So Fuchsia is built on these 4 pillars. If there's anything you walk away from this talk, it's Fuchsia is built on these 4 axioms, these pillars called secure, updatable, inclusive, and pragmatic. And it sounds very, sure, an operating system's secure, it's updatable, obviously I can go to like preferences and run an update. Inclusive, it's kind of an interesting word, we'll talk about that. And pragmatic, we'll also talk about that. So let's dive deep. Let's look at security first. The entire operating system has been designed with least privilege principle in mind. This is something that a lot of operating systems haven't been designed with in the past because they were a byproduct of their time. You didn't need to really think about that. Obviously, Mac, Windows, everything is secure, but when you're writing an operating system from scratch, you're thinking about how could I make this as secure as possible using current technologies, using things that we know now what work. And so the kernel is built, again, with security in mind. It is an early fork of another kernel called Little Kernel. Little Kernel was designed to run on low-powered devices, IoTs, all sorts of stuff. But Fuchsia is not designed for that. It is using that as a base in a lot of ways. And they forked it very early on into the development of Fuchsia. And Fuchsia is designed to run on really high-powered or low-powered, like all sorts of surfaces, devices. It's 64-bit by default. So you automatically you know the memory requirements Fuchsia has. And so the kernel is very secure. I'm not a security guy, but based on everything that I've seen and read, it sounds like Google knows what they're doing. The Fuchsia team knows exactly what they're doing. They have extremely brilliant people that are working on this. The one interesting thing that I saw as I was playing around with Fuchsia is that it's built on this philosophy of container first. Now, I'm not talking about Docker containers. I'm talking about containers in a in the operating system context where each application that you install. So theoretically, let's say I install Zoom.us or the Zoom video conferencing on Fuchsia, right? Zoom will only have access to Zoom. It will not have access to anything else in the operating system. For Zoom, the only thing that exists on the operating system is Zoom itself. Nothing else exists. It's on a lonely island. It's in a container. It has no idea of what runs outside of it, right? The only things it can talk to are things that it sees in its universe, which is exposed by this idea of services or protocols. And so everything on Fuchsia, absolutely everything, is containerized and modular. And when I say everything, I mean everything. Like, think about a driver. A driver is in a container. It is exposing some details that, hey, if someone wants to talk to me, they can talk to me on this protocol. And I have seen all these things that have exposed themselves. So if I want to talk to someone, I can talk to them via this protocol. That's it, right? And then when packages are installed on Fuchsia, it comes with everything installed. And this is one of the most beautiful things that I've seen when it comes to comparing operating systems. Again, I'm not an operating systems expert, but when you look at the way Fuchsia apps are installed, they come in this idea called packages. And packages aren't just like like a .exe or whatever. There's some extension on it, but packages come with everything a package needs to run, right? So imagine imagine the context of Zoom again. Zoom is built in, it's built in Rust, right? So Zoom needs a Rust compiler, or say Zoom built in Python, it's much easier. So Zoom needs Python to run. Now, in the Mac world, you would install, say, zoom.py, and you would go Python zoom.py. When you do where is Python on a Mac, you know that it's in user/bin/blah, blah, blah, somewhere. In Fuchsia, Python is actually built into the package, right? It's right there. So the package is shipped with everything it needs. This concept is called BYOR, bring your own runtime. And we have a quote from it right after this, but we'll talk about that. Whoops. Okay, so it's called bring your own runtime. So you might go, well, that's kind of a waste in memory. What if, like, there's 20 different Python apps. Each one will have its own version of Python. Won't that cause a lot of space issue? No, because the beauty of Fuchsia is it will look at these packages and it will go cryptographically, this Python version is the same as another Python version, is the same as another one, so they're all going to be shared in a blob store. So there's this blob store that Fuchsia has somewhere, and there's just a bunch of blobs there. And it's basically a hash map where they go, cool, I need Python. Python's cryptographic version is 001. Hey, there's a 001 in this blob store, and that is Python. So cool, I'm gonna use that. So that's how Fuchsia does storage management, I guess. And then containers run in their own namespaces, which also means that Fuchsia does not have the ability, does not have a global file system, right? Like when you think of a file system, say you're in like, again, let's just use Zoom for an example. If Zoom wants to refer to something on your My Documents folder, for example, Zoom internally, maybe there's some code written that does ... say to the applications folder, Zoom's installed. So Zoom will go ... My Documents, right? So it's going from applications, one folder up, and going to My Documents. On Fuchsia, you are not able to do that because each application, each package comes with its own namespace with its own file system inside of it. So if each application does ... trying to go to the root of the application is, the root for this application, the root is where the application begins. It cannot jump the container, it cannot jump its namespace and try to access files somewhere else. If it really needs to, it needs to know that there's a service somewhere that is exposing some file that it needs, and there's a way to share that using the protocol. So that's really around the security built in Fuchsia. And we'll talk about next why all the security is needed because of the way Fuchsia apps are updatable and how they're installed. Yeah, okay. So like I said, everything is a component, it's a package in Fuchsia. Absolutely everything from a driver to a network stack. Maybe there's a TCP IP stack. Well, that is a package on its own. It's living in its own universe, exposing a certain number of services. And when you want to talk to these applications, you got to use this thing called FIDL, Fuchsia Intermediate Development Language or something. Totally wrong, probably, but that's how you talk between these applications. Now, when you boot up Fuchsia, my emulator is not working, so I can't demo this, unfortunately, but when you boot up Fuchsia, say you go in and you type in mkdir, right? Make dir, and you type in a folder name. If the first time you run it, and this is Fuchsia in development mode, and this is a very key distinction. When you first run Fuchsia in development mode and you go mkdir, Fuchsia doesn't come with mkdir installed by default because it's the entire operating system just comes with what it needs to just boot up. When you run mkdir, it will go to user/bin, assume, and it will say, hey, is there an mkdir? And it turns out there is. It's a package. So it goes into that package, but it sees a file there that says, hey, Fuchsia, mkdir is actually located at fuchsia dev : / fuchsia.com/mkdir. So it's actually not even on the device. It's on a server somewhere, right? A package server. Think of it like NPM or pub or whatever. And so Fuchsia goes, cool, thank you. Oh, and here's this cryptographic hash, right? Like all the security built in. So Fuchsia goes, cool, thank you. Let me go to the package server and grab this component. It goes there, grabs it, downloads it, and then it runs it. So all this happens in near real time, depending on how big the application is, on your development device, obviously. And so the interesting thing about this is as you're building the operating system, first of all, these slides are not North American Connect. Anyways, as you're building the operating system, you can see that, if you've ever worked with Android development, Android OS, not the Android app, but actually building the Android OS, you gotta have all these applications built in. And when you make a change to like a system level component, you gotta rebuild the entire device. Why? Because that component needs to be embedded into the device when the entire operating system boots up. With Fuchsia, because it's all composable and updatable, it doesn't need to be built into the OS. So this is great for device manufacturers who are actually building these applications, who are building devices that they can choose what they want on the device, and they can choose to ship with things that they don't need, and the device will work fine, because components that it doesn't need, it doesn't require it to boot up with it anyways. And then when you're building it, a package server is running locally. It's not actually on Fuschia.dev, but technically, based on the documentation and presentations I've seen, you can actually have it, instead of going to Fuschia.dev, you can have it going to like https://fasalscoolpackageserver.com, pass in some like cryptographic identity, and it'll fetch the application from there. When you actually ship the device, it's not going to check in real time, obviously. It will have some components built in, whatever you chose when you're building the device. And then after that, it will check, say, based on the frequency you ask it to, every 12 hours, every 6 months, I don't know. It will check your server to see if there's a new update for this application. The beauty about this is, when you're doing driver development, for example, you get hot reload for drivers, right? You can actually hot swap a driver while it's running. And so that's really interesting as a developer when you're building complicated devices, that you can actually do an over-the-air update. The user doesn't even have to restart their device. It's just working, and one day there's a new version of the driver that automatically updates because it had like a security issue and it needed to force update, for example. So this is a little quote by the Fuchsia team you can find on their website. We're designing the system so that Fuchsia products can receive system updates without having to modify or recompile drivers. Drivers, system services, and end-user applications would be able to be updated independently through the same mechanism, reducing the maintenance burden, right? Device owners could receive Fuchsia updates without having to update their drivers. Very, very cool. For operating system developers, manufacturers, if you're working on your own devices, it's amazing. Now, this is something that matters to me even more as a developer, right? I probably will not, I used to 5 years ago or 7 years ago probably, actual Android ALSP and deploying it on a tablet, but I got out of that game a long time ago. So I'm probably not going to go back. However, I'm an app developer and I care about how do I build apps for Fuchsia. And this idea of inclusive comes from the idea that you can actually run any application you want. Any language, you can write an application in any language. Right now, Fuchsia supports Dart, Rust, Go, C, C++, but say you are an expert in Kotlin, right? And you want to build a Kotlin app for Fuchsia. You could do that. Remember, everything is shipped up in this bring your own runtime philosophy, right? So you could figure out that, cool, I'm going to get the Kotlin compiler and whatever Kotlin JVM and whatever to be packaged up in a Fuchsia package. And when Fuchsia runs it, it's going to say, cool, in order to run this app, I need this runtime. Here, you guys meet, run the application. And as long as your application and runtime conform to that service, that specification we talked about, Fiddle, your runtime will work fine. So this is how Fuchsia has been able to add support for Dart, Rust, Go so quickly. And this is how it's adding support for Android apps. It's adding support for Flutter apps. That support's already there. It's adding support for Chrome apps. Maybe PWAs will just be running as applications on it. So this is what I mean by it's built taking into our times in mind. Fuchsia is not saying, sorry guys, you can only build applications in Flutter. People would hate that. As much as I love Flutter, that would be such a limiting barrier to entry. So if you're a Rust expert, Fuchsia is perfect for you. If you're a Go expert, Fuchsia is perfect for you too. So here's another quote regarding bring your own runtime. Fuchsia simplifies the development model by making nearly all user-space software a component, from system services to end-user applications. The principle is known as bring your own runtime. So here's something interesting. If you want to build a, what's hot right now? Web3, right? IPFS. So if you want to build an IPFS network driver for Fuchsia, and you are an expert in Go, right? Technically you could write some Go code, and you can have a whole interface that defines it, and you can have Fuchsia connect when someone calls like the Web3 protocol, I mean IPFS protocol, it will call your service because you've registered it, and then your Go code will run and return a result back. Your Go code will run in its own container, and you know it won't know what else applications run on the server. If you really think about it, the way they got this idea is from Chrome tabs itself, and I think someone talks about this, where Chrome, each tab is living in its own system, right? Tabs can't talk to each other unless they go through some well-defined service that Chrome exposes. So this way, JavaScript can't like steal your data from one website to another. That would be insane. So it's the same idea behind inclusive applications. Lastly, and the most important one, it's not experimental. Fuchsia is by no means an experimental operating system, which is why I'm giving even a talk on it. This has real-world use cases already. The biggest use case right now is if you have a home hub, chances are that home hub is running Fuchsia. And this is the wildest story, and I don't know why more people don't talk about this. The Google team was able to, in real time, over the air, swap an operating system out and replace it with another operating system with absolutely minimal issues, right? That's wild if you think about it. Like one day, you're running an operating system on your home hub, you come back, you wake up, and it looks exactly the same, you have no idea, but the entire thing is different, right? It's like some like ship of thesis philosophical argument here. But that's what Fuchsia can do, and so Fuchsia is running in production. Do I think one day Fuchsia will replace Android? And this is a disclaimer, I don't know anything about Google's roadmap. So what I'm about to say, could totally be false, but I actually think one day, maybe in like 2 years, 3 years, or even shorter, the latest Pixel phone, say Pixel X, right? Pixel 10, might start off running Android, and one day over the air just get rid of Android and run Fuchsia, and no one would know. I mean, obviously people would know what's running on their device, but like no one would be able to tell the difference because Fuchsia will be able to run Android apps, right? Bring your own runtime. Fuchsia will have support for phone devices already because it already does for Home Hub. So you'll be able to quickly swap an operating system, and then, if you want to write a Go app on phones, go ahead. Fuchsia will allow that. So now you could have mobile apps being written in Go, in Rust, in Erlang, whatever the hell you want, right? And then one interesting thing is that unlike Windows and Mac, Fuchsia is a real-time operating system, so it's also designed to run on mission-critical hardware. You could theoretically one day run an entire rocket launch using Fuchsia because the properties of a real-time operating system, if you get into the computer science literature, allows, when something crashes, the entire OS doesn't die, it's keeping track of time accurately, all sorts of stuff. So these are the 4 pillars of Fuchsia, and when you walk away from this talk, I want you to remember these 4 things. When someone says to you, I wonder why Google's wasting time on Fuchsia, right? Why don't they just stick to Android? Well, these are the 4 reasons why that Android nor any other operating system right now kind of follows. One thing, this is another good quote by the Fuchsia team. Fuchsia makes heavy use of asynchronous communication, which reduces latency by letting the sender proceed without waiting for the receiver. This is important for delivering software that can come and go on device as needed to account for network latency. That is really wild, right? You could have like this idea of software coming and going, obviously keeping in mind all the security implications of it, and because Fuchsia is making it very secure, you could have a device that is like getting rid of applications that you don't need and keeping it there and bringing it back when you need them. Components, forget applications, right? Maybe you don't use your printer driver, but you need it when you do. It's just there, right? It just shows up. So lots of very interesting things into the operating system design. Now, before we get into a demo, and we won't be able to see a Fuchsia emulator because that thing's not booted up, but I'm going to walk through the code. Let's take a look at a high level how the entire Fuchsia operating system is laid out. So you have product experience at the top, right? UI, whatever. You have runtime, which is web, Dart, Rust, Golang, whatever you want stays in runtime. You know, as you install more, it's bringing your own runtime there. Then you have the system core. You have all the services that it needs. And remember, all these are composable. All these are updatable in real time. When you need it, they're available to you. Then you have your different sorts of file systems, blobfs to manage all the different blobs, packagefs to deal with all the different packages on the system. So each use case has its own little file system going there. And then you have all the drivers at the bottom. And then at the lowest level, you have the hardware. So if you are very deep into operating systems and understand this, you might see a beauty in this and how really nicely it's laid out compared to other operating systems, even Android, to be honest. It gets pretty wild. So with that in mind, let's do a demo. The one thing to do, I'm going to share the rest of my screen here so we can start doing some demos. Share desktop. Cool. So I'm going to bring in this emulator. You can see for some reason it has not booted up, RIP, I don't know why. So that is fine. So the first thing to do is actually download Fuchsia. Fuchsia is pretty big. I can never spell Fuchsia. It is the most complicated word to spell. So yes, okay, good, I spelled it correctly there. Okay, no I did not. Good. F-U-C. I cannot spell Fuchsia. There we go. All right, so when you go to Fuchsia Dev, everything that I've said also exists on here in one form or another, plus the presentations that I've seen. So first thing you do is you download the Fuchsia source code. Fuchsia is not an SDK. You can't just like grab an SDK and stick it into your Android Studio, unfortunately right now. So it's probably not ready for like, hey, you know, my application, I'm gonna build it in Flutter and it's gonna run on Fuchsia seamlessly. It's not there just yet. But you can start getting, you know, playing around with it to get your head across it. So Linux or Mac, download it. It probably won't work on Windows. So you install it, you get it all ready, bunch of steps there. But once you have it, you are basically exposed to this directory. And I'm going to open this up in VS Code here. Because we can't, unfortunately, see all the emulator commands here too. Sucks. All good. So close others. So I'm going to just make this bigger. And I will go to examples folder. So here, in the examples folder, here's all the example apps that Fuchsia comes with. There's like Fortune, Hello World, bunch of Dart apps. But here's what's interesting. If I go into Hello World, there's 3 versions of Hello World in the Fuchsia app. There's the Rust version for those Rust stations or whatever, C++ for all the C++ developers, and Dart. So let's see how the Dart code is. If I go into lib main, let's close that. That's it, right? That's awesome. That is a command line app that is built into Fuchsia that is built in Dart. So if you understand Dart, you can use this. You can modify this application, and when you run Fuchsia, you can type in hello world and it will run this application. If you are a Rust developer, let's look at the Rust implementation. Same thing, right? Hello world, whatever. It just works. It grabs a greeting, creates a string out of it, whatever. And what's interesting is, unlike, now this is where it gets complicated, you can't just like copy and paste your Flutter code and expect it to build. There's a whole build system called Ninja on Fuchsia that you need to kind of play by. And Ninja tells Fuchsia, hey, here's the applications that I need to talk to. So remember this protocol. So here are the protocols that I'm going to need to talk to. Here's the protocols that I'm publishing. So here in this hello world, for example, for this Dart app, it depends on the Dart SDK Fuchsia and then the Zircon SDK. And if you notice, // it means that it, it's going to be packaged into the application. It's not like looking at some global folder that has all these applications there. And And then it's just defining the manifest of how the application works, what's the entry point, the manifest. If you look at the manifest here, whoops, close, let me move this up. Okay, it just has a very small manifest. Some applications have longer manifests. But anyways, it's just showing when the application is installed, what is the command that it's going to be installed as, hello world Dart. So what's very interesting about this is, right now, if I were to say, is Fuchsia something you should like focus on and start building apps for? No, it's not ready yet. Is Fuchsia something that you should start thinking about if you are thinking about building devices, if you're thinking about building, if you're a team that works on mobile phones, IoT devices, I would say get in touch with the Fuchsia team. Try to understand, is what you're doing on their roadmap, how much support you can get. I want to say that the Fuchsia documentation is fantastic. So if you go over all the guides, you can learn exactly how to build and deploy applications. I'm going to show a screenshot. Here's all the applications that Fuchsia supports right now. Python's there, Rust is there, Go, Dart. That's just because those runtimes have been written. You can bring your own runtime, remember, right? How to bring a new language to Fuchsia. If you read this documentation, you can figure out how to do this, right? So unfortunately, my emulator did not work, but I am going to show how the emulator is. So I don't want to get anyone's hopes up. This is how the emulator is, right? This isn't like, we're not talking about Android Studio or iOS simulator with really fancy designs. It's just a simple emulator where you can show your applications. Then this is an older version of it too. The new one looks even more primitive. But anyways, that's all there is. By default, when you run the emulator, it comes with a simple browser application where you're actually able to like browse the internet. And what's wild is you can like watch YouTube and stuff on it. It is wild how mature all the rendering engine and everything is. Then you can run terminal, then there's a bunch of sample apps like I was showing you, Hello World and stuff. So with that in mind, I want to say thank you. If there's any questions, I'm happy to take those questions. Otherwise, check out fuchsia.dev. You can also follow me on Twitter, add me on LinkedIn if you have any questions. Maybe I'll be able to answer it, maybe I won't. There's also a great Discord for Fuchsia developers where I actually, just reading all those messages, I've been able to learn a lot on how Fuchsia works, and they answer all my questions. So thank you I hope you learned something about Fuchsia. I'm going to turn off my screen share.
We do have a few questions in our Slack channel from Dennis Gabo. How does Fuchsia compare in performances with Linux or other OS? How much is the overhead of having everything in a sandbox container communicating through a protocol?
Yeah, it's too early to say that. I have never done performance metrics compared these different applications. I know that it's still early. If you read through the documentation of Fuchsia, many places they talk about, we haven't like optimized this for performance yet. However, if you go look at like the Home Hub, it works pretty well. If you look at the YouTube videos comparing Chromecast, I guess, whatever was running on Home Hub versus now, Fuchsia, they look identical in performance. But I would say for, it's not intended for desktop just yet. There's no like desktop GUI. So it's probably not as performant as Linux at the moment. I would say eventually probably it will get there, even probably faster, because you're talking to all these containers, but they're going to be optimizing those channels. So I think it'll be equivalent to Linux, if not faster.
And we have an additional question. So theoretically, you could package ART as a runtime and run an Android app in it?
Yes, and that is what they're talking about. If you look through their roadmap, you can see commits and stuff for ART, and yeah, Dalvik's long dead, ART, right? And talking about building Android apps, which is why, again, I don't know any internal Google response to this or any roadmap, but I do think in the next couple of years, we will have a Pixel phone or whatever branding there is then that will have Fuchsia running, with all the Android apps running, there'll probably be some changes to SDKs that you'll have to make for your Android app because of the containerization. But Android's already getting there, right? You can't just write stuff to file system anymore. You have to use file provider and all that stuff anyways.
And also for awareness, the room has been unmuted. So if you'd like to come off mute and ask a question, that is available to you as well right now.
Cool. Thank you. Thanks, Russell. Yeah, I would recommend everyone check out Fuschia.dev. Also, the two videos, Rubber Duck Engineering has a great hour-long or an hour and 20-minute long video between Eric Seidel and Adam Barth. Adam Barth works on the Fuchsia team. So, and actually he's an amazing guy. You just message him on Twitter, he'll respond to you. He's done that to me many times. So do follow him on Twitter as well. And yeah, check that video out. You'll learn a lot. Thanks, Barrett.
We have one additional question that came in on Slack. Is there any part of Fuchsia that makes it easier or seamless to create a multi-device communication? Or to create multi-device communication?
Yes, actually there is. And this, I haven't done a lot of research into it, so this could all be misinformation. But when you watch the Rubber Duck Engineering talk, no, there's another talk that I will link in my presentation. They talk about Fuchsia building, and this was 2019, so it could have changed by now, but building, I guess, using the Ledger protocol and building something that's able to sync multiple devices together and share data with each other in a very seamless way. So this is something that they have talked about. I'm sure you can find it online as well as in this YouTube talk that I found. Cool.
Looks like we have a follow-up coming in.
Cool.
So like having the current state of the app be transferred seamlessly to another device and just resume where it left?
I don't know about that. Maybe. I mean, if you're transferring data, I can assume you can transfer app state data. I don't know if Fuchsia itself is making this easy, but the fact that they're working on some sort of technology protocol where you're able to share data easily, and I would, I would bet that this will probably be something that they'll work on, simply because of this idea of, they're building an operating system for the current times we live in with multiple surfaces. And so it seems very reasonable, especially reading what I read on that presentation, that this could be supported. Again, this could all be misinformation, and I'll probably get an email from someone on the Fuchsia team soon. Cool.
Awesome. So I think that is the last question that we have coming in.
Awesome. Oh, we have one, or we're
no, that was the last one.
Okay, cool. Well, thank you, everyone. Yeah, check out Fuschia.dev. I think the future is very bright for it. Cool. Thanks, Etienne.